Okay, this is a video recording of lesson 13 titled More Types of Software Testing. And as we talked about with lesson 12, we're splitting the tester role, the software tester role, or the quality assurance role into two different roles just for teaching purposes. And one of the reasons we're doing that is because with lesson 12 and with unit testing, we really wanted to get into specific technical details about how you write unit tests to test your code. We really wanted to see that in exact detail. But with lesson 13 here, we're kind of going to take the opposite approach. We're just going to kind of go over a few different types of software testing, and it's not going to be comprehensive. It's not going to cover everything that people do to test software. Obviously, there's a lot of different stuff in that field, but the goal of this is to give you some perspective on the different ways people try to test their software, or how different software development teams, the methods that they will use to test their software. So software testing is a field that is constantly evolving in terms of the methods and the techniques that various software development teams use, throughout the field. So, there's not like one way that someone is going to test software, that a team is going to test software, or that a team is going to think about software. And kind of my illustration of that is this Google search here. If you just Google type software testing, you see a lot of different diagrams that are not consistent with each other, that formulate different types of testing in different ways. And the fact that you're seeing these differences should be a signal that there's not like one way to test software, or one way to think about software testing, or one way to formulate all the different types of software testing. So that's kind of my illustration of that. And if you were to Google something along the lines of pillars of object-oriented programming, or Maslow's hierarchy of needs, you would see diagrams that are very consistent with each other, because those are well-defined topics, and this is less so. Okay, so one of the reasons for the variation across the field is, it depends on how much a team wants to invest in testing. Testing isn't free; it costs money. So, there's a decision there, and then it also how you test is going to be dependent on what you want to get out of the testing. Do you want to get software that is user friendly and makes the users happy and meets all the requirements and the needs of the users? Is that what you want to get out of your testing, or do you need to get reliability out of your testing? If you're designing an airplane or something, you're going to want to make sure your software is highly reliable. Do you want to get the security out of your testing? Like, do you want to ensure that if you're processing payments or whatever, or you want to ensure that you're not leaking credit card information or anything like that? So, is security an important part of your testing? There's various different things you'll want to get out of testing, and so that will also impact, how you think about this topic. So here is one diagram or formulation that I found multiple times when looking at various learning resources about software testing. And so I figured I would put my own little version of the diagram here, just as something we can talk about in this space. So with this diagram, we're seeing that testing could be it's kind of on a spectrum of being really close and to the code, or being kind of far removed from the code. So on the bottom here is C#, and we have unit testing, which we saw you're directly working with your C# code. In our case, it's C# code, to validate and interrogate each little piece of code that you have, each unit of code, to ensure it's functioning properly. So unit testing is very, very tied to the code of the software. And then integration testing is still, it's kind of a level above that, and system testing is Another level above that, and then acceptance testing. When you're in acceptance testing, you're really at the how the user is perceiving the software. Does the user think the software is functioning correctly? So from code to user, you have the spectrum, and across the spectrum is various types of software testing, various levels of software testing. So from the perspective of this course, the most granular level of software testing is the unit test, as we said, and that again is testing individual methods of your code and ensuring that each of those methods is working as expected. And different courses are going to have kind of a different range of how granular they look at code or software. And but that's for our course. That's where we're at. That's the unit tests are the lowest the lowest level of testing. Okay. And as we saw, the one great thing about unit tests is they can be ran automatically, right? Because they're written in code. Unit tests are written in code, and you can of course run code automatically. So that's one great thing to observe about unit tests. They are kind of automatic by definition, and of course they're useful for catching bugs early. So we saw you don't need a full functioning application to be able to start testing your software. If you think to the cookie jar app or something, you couldn't actually without unit testing you couldn't actually test that software until you completed problem 2 of the homework, and right and with unit testing we can now test earlier on, so we can catch bugs earlier. And a kind of a general rule there is the earlier you catch a bug, the cheaper it'll be to fix. So if you catch a bug, 30 minutes after writing the code that bug was located in, then that's a cheap fix. That costed you, 30 minutes of time, not too much money. If you catch that bug after you've deployed the software, maybe you deployed software that's part of an airplane or a self-driving car or something like that, and you catch the bug, after a catastrophe of a plane crashing or something, then that's a very expensive bug, and that's not great. So sometimes it's very important to catch bugs early. We saw that unit tests were good for documentation, and kind of one thing to mention is we may have mentioned it last time, but it's also could be really good for the reliability of the software if a programmer that writes the tests is different than the person who wrote the code that it's testing. Again, just if you try to poke holes in other people's designs, it's going to lead to more robust code. Okay, so another idea here that we may have talked about last time, again, is test-driven development. And that is you write the code that tests the code before you write the code itself. And again, this can lead to good design, right? It forces you to think about how code should work, how you want to use the code before you actually write the internal details. So it can be a good design tool. It could also be a frustrating process if things are kind of changing or designs are changing often. So I particularly find it helpful if I know I need something, I need some functionality out of some code, and I kind of think there's a high likelihood I implement the functionality wrong. I screw up the internals of the code, and in that situation, I think it's really valuable to write the unit test first, because not only is that going to get you thinking about how you want to use the code more precisely, but then you're also going to have tests already to ensure you did it right. And the tests are not going to be biased based on your implementation. So I literally have Excel documents or sheets in my notebook where I've written out a test either by pen and paper, and then coded that test in my unit testing suite, or an Excel document that maybe is performing a calculation using Excel formulas and so on, and I do that in Excel first, and then I code the test, and then I actually write the software that's going to perform that same calculation, but instead of in Excel, in C#. So it really gives you confidence that the code you're writing is accurate. So test-driven development can be a great tool. And here's a little diagram here, but kind of what they say is write the test first, and the test should fail first, and then you write code to make the test pass, and then you maybe clean up the code afterwards once the test is passing. So that's a little TDD cycle diagram there. But anyway, moving on to the next level is integration tests. So integration tests are also typically code that can be ran automatically, although you may need some more information, such as like maybe a login ID or password, something like that. You may need some other data to put into your integration tests to make them work, but generally they can still be ran automatically and are still written in code. But the difference between integration tests and unit tests is that these are now testing whether different components of the system are correctly working together. So my example here is, if a YouTube channel uploads a new video, and you want to test that subscribers to that channel receive a notification on their homepage. So here you have two modules of the system working together. You have a channel's upload interface, and you have the homepage interface for all the users that subscribe to that channel, and those are connected in some way. And the integration test is something you can write to test that they're working together. Okay, so things become a little more complicated or nuanced when we get to the level of system testing. So with system testing, we're no longer testing individual pieces of code or individual modules of code. We're now thinking more about the app. Is the app working as it needs to? Is the system working the software system working as it needs to? So this is a level above those code details. And so to do system testing, you typically need a test environment. So your production environment is, if you're YouTube, right? It's youtube.com. That's your production environment. And you may not want to test there. You may have a test environment that has some test channels and some test videos and some test users and some test comments, right? So a test environment that kind of mocks your production environment. And in this test environment, system testers can test the system, right? And so we can split this testing into two categories: functional testing and non-functional testing. And functional testing is, if you, it's not too hard to imagine. You have a tester, and their job is to go into the test environment and perform certain actions and validate those certain actions produce the correct result. So if you're testing for YouTube, you go into the test environment, you like a video, you ensure that the like counter on the video goes up by 1. Or maybe a more complex test is when the likes on a video go up drastically in a short period of time, or a video reaches more than a certain amount of likes, then that video gets advertised to different users more aggressively, right? So that might be something a functional tester is testing. The correct thing is happening in the system when certain conditions are met. And the other one there is non-functional testing. And with non-functional testing, it's not about ensuring an action produces a result. it's ensuring other things such as performance. So is the action producing a result in a acceptable amount of time, or is it taking too long? So that's testing the performance. We're testing the security, right? Is this system susceptible to leaking credit card information, something like that? The reliability, right? So functional, non-functional testing. These are system testing. It's a lot of the times it's manual testers that are physically doing it, and it can be automated in some ways, and we'll see a bit of that. Okay, and then this last level is acceptance testing, and this is performed manually by actual users of the system. And this is just one last check to ensure that the software works as the users expect and need it to. So the difference between these two is that system testing is done by the software development team. They work closely with the rest of the team to ensure they're producing good results. And acceptance testing is not done by the software development team. It's done by users. So beta testers, for example, they are doing acceptance testing it's just one last check to ensure the software meets requirements. Okay, so that was the 4 levels of software testing, and we're going to move on from that and just talk about various other types of testing, or various testing tools, or kind of niche types of testing. So first thing we'll talk about is test plans in Azure DevOps. So this is a module in Azure DevOps that a team of testers might use to track various test plans that they work, where a test plan is essentially a set of actions you will take to validate that the software meets requirements and doesn't have any major bugs. So here's an example of a test plan. I pulled this from the website. So you could imagine a tester for Amazon, maybe for this example. And they have this test plan of how they're going to test the cart functionality. And they have a set of steps that they have written down and recorded in a test plan that says, well, first, if I'm testing the cart, I'm going to go to a browser, navigate to the home page, and then log in. And then I'm going to find a product and add it to the cart. And then I'm going to go to the cart and validate that it has the item I added in the cart. So these are the actions you might take, and then you write this test plan, and then you execute this test plan as needed, and you can check some boxes, say, okay, that worked, this encountered an error, and then you can write down why, what caused the error, or what the error looked like. So in this case, it was a 404 error. So the idea here is you're writing down and you're formulating your plan for testing, both because a big piece of software is going to have a lot of different tests, and you're going to, naturally you're going to forget every little thing that needed to be tested in a certain part of the system. But also, if you think about continuity, like if I'm the main tester for a system, and then I move on to testing a different system, and someone new comes in, well, now they have all these test plans that are written and documented down of things you do when testing certain parts of the system. Okay, so that's the idea of test plans, and if you have a really kind of involved testing organization, you might have a whole systematic framework for how you write these test plans and so on. So that's the idea. It's a feature right in Azure DevOps. There's a reason for that. It's an important part for a lot of software development teams that they have this systematic way for recording their tests. So another type of testing here that's a little more specific is regression testing. And the idea of regression testing is simple. It's just that as you add new features to your software, your existing features don't break. are still working as expected. And so you can do regression testing on all levels of software testing. So you can have unit tests that validate that your units are still working as expected as you added new units. You can have test plans that are for regression testing that note that, okay, every time we release software or features related to this functionality, we also need to do this set of test plans that are regression tests for this functionality, making sure everything the functionality previously did still works according to these test plans, and the new thing we're doing works as expected. So, that's the idea of regression testing, and having formulated regression tests, it can really build confidence and support high velocity development. Because if you can change software and as quickly and as systematically as possible verify that everything the software previously did still works, well then you have a kind of a foundation for being able to continually release new changes to your software. Every time you release a new change, you can do all the regression testing quickly, and then you'll be able to put out new releases faster and faster. So that's the idea there. So now we'll break for a demo here to show kind of Azure DevOps testing tools here. Because I'm not a paid user, it's not kind of I'm not going to show everything. It's just kind of to give a little taste of some of the stuff Azure DevOps has. Okay, so here I'm in the test plan section in Azure DevOps, and I don't have everything available to me, as I said, but I'm going to, it's suggesting here that I install a extension here to test web applications and submit feedback. So I'm gonna click install now, and it's a browser extension. Okay, so I'm going to install it for Edge. That's what I'm working in right now, and I actually already have it installed, but let me remove it and then install it again. Okay, and now it's added. So let's hook this up to our Azure DevOps. So what it's going to want here is the server URL. So that should just be this right here, dev.azure.com/software-dev-tools, and paste that in here, and hit next, and then select the team. I'm going to select the course public team here. Okay, and now I have this testing extension that is hooked up to this Azure DevOps project. Okay, so what I can do now is I'm going to close these install links here, and let me just go to icon. And let me get this extension up, and let me start a new session. Okay, so now that I have the session started, I can start performing actions in my application. So I'm going to click the login here, and what I can do here is, well, let me do this first. I can take this and capture a screenshot here in the browser, and grab that and give it a name. So login screen. Okay, save that, and then I can perform the next action. And here, grab another screenshot here, and do like 2-factor auth screen. Right, so we're documenting actions we're taking, and the how it looks in the application as you take those actions. Okay, two-factor auth's complete. And what we can do now is, let's go over here, and I'm just going to run a little test in Icon for simulating a student leaving a comment with an attachment on on a Icon assignment submission. All right, so before I do that, I'm going to go to this, and I don't want to screenshot every little thing, so I'm going to click record screen. Okay, start recording. Okay, and add a note, testing, leaving a comment with attachment on Icon submission. Right, some note here. Okay, so I'll click on this, and the interface that instructors have for doing this is the student view. So the student view gives me a way to kind of imitate a student here in Icon. And I'll go to an assignment, and let's do assignment 2. Submission details, and I can leave some comment here like attached is a picture of a diagram we will talk about later. Okay. Okay. Attach file. Oh, choose file. And we'll grab this file here. And we will save. And oh, it didn't work. Trying again. And it doesn't seem to be working. Okay, so let's leave student view real quick. Okay, so that's interesting. So the instructor. So now I'm in the instructor view, and it looks like I can see the diagram. But let's get back to student view. And let's go to homework 2. Okay, so now the student can see the image. Okay, so what we can do now, I mean, if you see, I had to leave student view and then come back. So let's create a bug here. So create bug. So when write a title for our bug. So can't see attachment on comment when or until leave and come back. Something like this. Maybe as student. Yeah, okay, let's try that. Okay. And then here you'll see it has a log of everything I did. Okay, everything I did to get into that situation, there's a log of, and I can save this. Okay, and here's the session timeline. So this is kind of related to that log we saw, and it has those screenshots I captured at the beginning of the process, but then it also has that video when the screenshots were too inefficient. I just wanted a whole video, and Yeah, and then here's the bug I filed. I filed a bug as a result of this session. So now let's stop this session here, and let's visit Azure DevOps over here, and let's see if we can see anything here. So still nothing here in test plans. Nothing in progress reports. Yeah. Here we go. Test runs. Recent exploratory sessions here. Okay, so I don't know what this is, but this is an old test. But here you can see kind of recent sessions I've been doing. So I've created a test case based off of stuff I've done in that extension. I've created some bugs. I've had 8 different testing sessions here. And if we go over to work items over here, here we can see the bug that I just filed. So as a student, can't see attachment on. Yeah, so here's that exact bug that I found during that testing session. Okay. Here's all the yeah. Here's the screenshots. Here's everything I'm doing, and then yeah, keep scrolling, and here's the screen recording. So this is all recorded in Azure DevOps. Now, everything I took as a tester. And this is going to be really helpful for your development team because we can see how the tester found this bug so that we can recreate it on our end to figure out what went wrong. So yeah, and so here's that whole recording of everything I did. And here we have more system details, like my operating system, Windows. I'm not using Google Chrome, so I don't know why it says that. But some more details about sometimes the browser the tester's using can impact things. So we get all that there in the video. We have the log. We have attachments. So really great integration here. Great for testing web applications. I think they have extensions for testing desktop applications as well. But I don't come from a testing background, at least not in this way. So I don't have full exposure to all the different things. But yeah, so that's a taste of the extension here and the integration with Azure DevOps, and we will move on in the slides now. Okay, so the previous few slides and that demo were touching on manual functional testing. So a user or a tester physically going into a system and performing these actions and documenting what they're doing and writing down their test plans and so on. So that's manual functional testing. But there's also tools for automated functional testing, and so these can help you perform routine tests or regression tests automatically so that the tester can spend time testing new things rather than repeatedly testing routine tests. So there's some tools in the space for this automated testing. So here's one. Selenium is an open source automated testing tool for web applications. And here's another one, SmartBear Test Complete. It's commercial software, and you can test web apps, mobile apps, desktop apps, web APIs, and so on. So it's a very robust testing product here, testing automation product. And to be clear, I don't endorse any of these products. They're just products I've heard before, and that's why I have them here. So we're going to look at a clip of a video showing Selenium here, just so we can see the automation happen.
So it's
Here, let's mute it here. Okay, so okay, yeah, so right here. So here we can see this like master Excel sheet. There's like 10 different tabs here. And what you define in this Excel sheet is actually really cool because you're writing a test script by using Excel. But this Excel document is denoting steps that need to happen. If you're familiar with web development, you can leave IDs on different fields. So you can have a field called email, and the action that needs to be performed is enter text, and the text that'll be entered is located in a different tab here in Selenium. And so what you've defined here is an automated set of actions that need to be taken to test a certain functionality. So it's a lot of entering text and a lot of selecting elements, and we'll see exactly what this is testing here in a second. But here's the data. Okay, so this is the actual text that ends up getting entered within the application when you run the test. And so we'll see here what this is testing is the Facebook login page here. So this, yep, so they're going to run the Selenium. Selenium's going to read that Excel file, and based on what's in that Excel file, it's going to see, okay, I got to launch facebook.com, and this is all happening automatically. There's no user, and you can see it's just entering as if it was a real user this data. And after it does this you can perform some validation uh, to kind of assert that the correct thing happened, or if it didn't find something it was looking for, if Selenium didn't find something that it was looking for, it can report that in the report that it brings back. So this is an example of what an automated testing tool might look like. And the nice part about this is if you have tests that you're consistently running, it's a great candidate to be automated. So you define that test in the Excel of Selenium, and you can run that. Okay, so that's an example of that tool here, or an automated testing tool. So now we'll talk about some types of non-functional testing. So this is testing that is done for purposes other than assuring that the software has the correct behavior in certain circumstances. So this is testing things like the security, the performance, or how well the system works when there's high traffic, and so on. So the security testing we'll start with here. Uh, the first way you can do security testing is, of course, by hiring some form of ethical hacker, right? And they have experience in breaking into systems and extracting confidential information out of systems, or exploiting systems to do something bad, or bringing systems down using various types of attacks. So there are people that get paid to do this kind of ethical hacking to see if they're able to exploit a software system in some way, and that would be manual security testing. But there's also some automated tools that we're going to mention here with security testing. So these are the three here: static analysis tools, penetration testing tools, and threat modeling tools. So static code analyzers are an interesting tool. So they look at your code and determine if that code is susceptible to any kind of security flaws. So they kind of simulate the various kind of code paths that can be executed in the code, and see if that if there's any security flaws based on that. So it's it's here's this is Fortify Static Code Analyzer, and you can see like this is the tool, and this is your code that you wrote, and it'll say, well, on this line, you have a I don't know if you can quite see it, it's small, but it says, on this line, there is potential for a cross-site scripting security vulnerability, and here's the evidence, so the analysis evidence down here. Like, this is all the things that happened in the program before this line, which leads to there potentially being a cross-site scripting vulnerability in the software. So it's very it's very involved with your code, and it's for programmers. I mean, they're the ones that are going to kind of understand the code best. So, but it's also good for security auditors, maybe even people who don't write code, but they can use a static code analyzer to review code and then kind of audit developers and say, well, why is your code producing this vulnerability? Is this okay? Like, is this intended functionality, or is there something wrong here? And so, that's the idea of a static code analyzer. Really powerful tools, and they don't have to be security related. They could also just detect basic things like, is there code that's not following a naming convention? Yeah, there's tools for that. So, well, this is supposed to be camel cased, but it's Pascal cased according to our company's convention. So they can also do that. They can determine if you're collecting confidential information from a user and you're not taking care of that confidential information in your code. Are you encrypting this information, right? So they can really determine really fine-grained security details about your code. So this is one tool we have in this space here. Okay, so the next tool we have in this space is penetration testing tools, and how I view these tools is, I haven't used them before specifically, but I view them as, we talked about ethical hackers that you can pay to try to attack your system and see how it can be exploited. This I view as kind of the automated version of that. So it might not produce as good of results as an actual attacker or an ethical attacker or hacker, but it can be automated and it's probably cheaper, and it is going to use similar techniques that an actual attacker would use to try to exploit various parts of your system. And it's the reason it's called penetration testing is because it's going to see how far it can get into your system and what damage it can do based on how far it gets. So, an interesting automated tool. I'm not exactly sure how the technology works, but this one here, this product is called Insight AppSec, and it does exactly that. It sees how far it can get into a system to either breach information or maybe create a denial of service attack where the system is now not operational for actual users, or can it use the application to kind of attack other applications in your company's organization, for example. So that, there's a lot of things that can happen here. So this is kind of an automated tool for that. This last one here is threat modeling. So threat modeling is essentially just diagramming of your system and the valuable assets in it, the risks in your system, how data flows through the system, where users connect to the system. It's a diagram of all of that, and you use these threat models as a tool to be able to talk about and review and assess the security of your system. So here's a little threat model here. This one's looks fairly complex, but The idea here is you have these boundaries, and these applications here, or APIs, or modules, or IoT devices, whatever it is, if they exist in this boundary, they're kind of part of the same family, and then uh, when you leave this boundary, when information leaves this boundary and enters a new boundary, then that's something you might need to consider. Like, well, are we making sure we're not leaking information out through this boundary, or this boundary isn't prone to being exploited? So this is a modeling. It's just a modeling tool for building these diagrams, and you see there's some really interesting stencils here in this tool. Like, I mean, these are all like IoT devices, web servers, computer stuff. But you'll see in the stencils there's like ionizing radiation source, um, a safety interlock, a pharmaceutical pump, right? So I mean, this isn't sensor. This isn't just for computing technology. I mean, you're also getting into cyber physical systems, and how can, you know, is there some exploitation at a nuclear power plant that an attacker can work their way through to compromise an ionizing radiation source, something crazy like that, right? So that's what threat modeling is these system diagrams for that. So I'm going to show a simpler threat model here as a little demo here. So okay, so this is the Microsoft threat modeling tool. So actually, let me show you where you get that from while that loads up. So if you just go Microsoft threat modeling tool. Yeah, here it is. There's a Microsoft web page, and you can download the tool. Right here, yeah, download the threat modeling tool. Yep. So that'll get you the tool, and you can use that. Okay. So if we look at this diagram here, so this is for a system I'm working on here, and you can see we have this boundary. This is the local user zone. That's this boundary, and this there's an application here called Unified Data Explorer, and the user is going to work directly with this application, and this application is going to need some user credentials that it's going to store in an encrypted manner on the user's machine. And so we see that here. So this is okay as long as we're encrypting the credentials that we need on this machine, and it's staying on the machine. There's no threat yet. Okay, but if we look, this application is going to connect to some external APIs, and it's going to need those credentials to connect to these APIs. Okay, so that's the connection here, and we're not responsible for these APIs. These are external APIs. It's different software that handles it. So we aren't too concerned about the security of these. But then the interesting thing that happens is not only can a user or of this software enter their credentials and then interact with these systems, they can also interact with our system here called the Emissions Monitor API. And they might want to use this API in the case of this system to do like complex analysis on a lot of data. So you'll see these are three machines that are together here in the same machine trust boundary. So the API trusts the database that is connected to, and there's also this experimentation application that sits in proximity to them, and these all trust each other. But this request can go off to the API, and then the API can run an experiment of some sort or an analysis of some sort that might take a long time. So that's why it's done over here with these other machines that might be located in the cloud. And so if we want to think about the security of this, we might have a vulnerability if, say, for example, the user doesn't have access to these two APIs, okay? And now the user is still able to connect or target these APIs through our API, right? So this is something we want to consider. The exploit here, I think the technical term or one of them might be like it would be server-side request forgery. So as a user, I don't have access to these systems directly, but by going through this API, I can forge requests that go off to these APIs and maybe get data that I'm not authorized to view. So that's just a simple security example of looking how you can kind of exploit a system component to get information from other systems. So so there's that example here. It's a little threat modeling tool. Okay, just a few more slides here. So load testing. Load testing is, again, non-functional testing, and it's testing how does the system react to heavy usage. Is there particular errors that occur when load is high, or what bottlenecks exist in the system? Are we constrained by compute, or are we constrained by memory, for example? So figuring out bottlenecks, or is there a particular system component that is bottlenecking us? Is it our API, or is it the database that's creating the bottleneck first? And this type of non-functional testing almost certainly is going to require automated testing tools. So, I mean, if you imagine, how do you test the scenario when 1 million users connect to your system? Well, you'll either need 1 million users, or you'll need some tool that can simulate 1 million users. So that's kind of what this is about. And this is out of my domain here. So I don't know any of these tools, but here's some load testing tools that can do that for you. So a system administrator might be the person managing these tools, or one of these tools to test this. Okay, and then just to conclude on this lesson here is just other types of testing. I mean, the list goes on and on and on and on. And so one that I thought that was interesting, a student brought this up to me after our unit testing lesson, but patent testing. Apparently there's a type of testing that you want to ensure any code that you have a patent on, you want to make sure that code is not shipped into a country that will not honor that patent. That's a very special case of testing. I don't know that I've ever written code that is protected by a patent, but companies certainly have this type of code, and it's one way they want to protect their intellectual property there. So they need to test for that they're not shipping patent-protected code to places that don't operate, that won't honor the patent. I don't know what most of these are, honestly. Cross-browser testing, yeah. So it works in Firefox. Does it also work in Chrome? Does it work in Safari? Right? Type testing. Yeah. You could take your guess as to what these other forms of testing are. I'm not entirely certain. So, all right, that is it for lesson 13, other types of software testing.